Good day, students. Now we have the sixth lesson. This lesson is practical lesson, and we will have several examples about the mathematical expectation and the variance of the continuous random variable. Now, first write the first example. Example 1. Find the variance. The variance of the continuous random variable of the continuous random variable with the given distributive density, with the given distributive density, given distributive density, colon f of x is 1/4 in the interval minus 1 3 and f of x is 0. Outside this interval. Outside this interval. Interval solution. Example first. Example 1. The infinite interval from minus infinity to plus infinity is divided into three intervals by the points minus 1 and 3, and therefore we will obtain three intervals. The first interval is from minus infinity to minus 1, that is until minus 1, then between minus 1 and 3, and finally after 3, that is the interval from 3 to plus infinity. Draw these intervals minus infinity to plus infinity. Here minus 1, 3, and we have three intervals. And therefore we can rewrite the condition in the following form. For the distributive density, it is f little of x. F little of x equals 0 for x is less than minus 1, 1/4 for x situated between minus 1 and 3, minus 1 is less than or equal to x is less than or equal to 3, and again 0 for x is greater than 3. That is, here f of x is 0. Then here between minus 1 and 3, f of x is 1/4, and after 3 f of x again is equal to 0. First check the main probability equality for the given distributive density. That is verify the formula, integral from minus infinity to plus infinity f of x is equal to unit dx. I'm sorry, dx. We must add dx. Add dx. Dx is equal unit. It is the main probability equality for the continuous random variable. Divide this integral into three integrals. Integral from minus infinity to minus 1 f of x dx, plus integral from minus 1 to 3 f of x dx, and plus integral from 3 to plus infinity f of x dx equals. In the first and the third integrals, f of x is 0, and in the middle integral, f of x is 1/4. Right? We have integral from minus 1 to 3, 1/4 dx. Here, 1/4 is the constant factor, and we can take 1/4 out of the integral symbol. Then equals 1/4 multiplied by integral from minus 1 to 3 dx equals, here the integrand is unit and its antiderivative is x, simply x. 1/4 multiplied by x with double substitution from minus 1 to 3. Then 1/4 multiply, first substitute 3 instead of x, then minus, substitute minus 1 instead of negative 1 instead of x. 3 minus negative 1 equals 1/4 multiplied by 4 is unit. Thus, we verified the main probability equality for the continuous random variable. Then, in the second step, calculate the mathematical expectation. Second step, other expectation is calculated by the its formula, integral from minus infinity to plus infinity, x multiplied by f of x dx. Equals, it is formula of the mathematical expectation for the continuous random variable. Again, divide this integral, separate this integral into three integrals. Integral from minus infinity to plus infinity. I'm sorry, minus infinity to minus 1. To minus 1. To minus 1. X multiplied by f of x dx. Plus integral from minus 1 to 3. X multiplied by f of x dx. And plus integral from 3 to plus infinity of x multiplied by f of x dx equals. In the first and the third integrals, f of x is 0 according to this figure. These intervals, f of x is 0. And you know that the definite integral of 0 is 0. But here in the middle integral, substitute 1/4 instead of f of x. Then we have integral from minus 1 to 3 x multiplied by 1/4 dx. Here 1/4 is the constant factor, and we can take it out of the integral symbol. 1/4 multiplied by integral from -1 to 3 x dx, and here integrand is x and its antiderivative is x squared in half. 1/4 multiplied by x squared in half, with double substitution from -1 to 3. Then calculate 1/4 multiplied by 3 squared in half minus -1 squared in half. Then 1/4 multiplied by 9 seconds minus 1 second. It is 8 seconds, and it is 4. 1/4 multiplied by 4 is unit. It means mathematical expectation is mx is unit. Continue, go to the third step. In the third step, we must find the mathematical expectation for x squared, or the square of the continuous random variable. That is, we must find mx squared. Again, write the mathematical expectation according to its formula, and now we must find mx squared. If calculate mx squared, we must x squared instead of this x in the integrand, x squared. That is mx squared equals integral from -infinity to +infinity x squared multiplied by f of x dx equals. Then again separate the given improper integral into 3 integrals. Integral from -infinity to -1 x squared f of x dx, then plus integral from -1 to 3 x squared f of x dx, and plus finally plus integral from 3 to +infinity x squared f of x dx. In the first, in the third integrals, f of x is 0, and in the middle integral f of x is 1/4. Continue. Equals integral from -1 to 3 x squared multiplied by 1/4 dx equals. Here 1/4 is a constant factor which can be taken out of the integral symbol. Then 1/4 followed by integral from -1 to 3 x squared dx. Here integrand is x squared and its antiderivative is x cubed divided by 3. 1/4 multiplied by x cubed over 3 with the double substitution from -1 to 3. Then continue. 1/4 multiplied by 3 cubed over 3 minus -1 cubed over 3 equals 1/4 multiplied by 27 thirds minus -1 third equals 1/4 multiplied by 28 fourths. Simplify numerator and denominator by 4. Here 7, here will be 1, and we have 7 thirds. That is mx squared. mx squared is 7 thirds. And finally, find the value of the variance. We can find the variance. Find the variance. It is last step, fourth step. dx equals mx squared minus square of mx equals mx squared is 7/3, and you remember that the value of mx is 1. 1 squared is 1, and our answer is 4/3. It is answer of our example. Now consider next example, example 2. Find the variance of the continuous random variable with the given distributive density. F of x is sine x in the interval 0, pi in half, and f of x is 0 outside this interval. According to condition, we can separate the infinite interval from minus to plus infinity into 3 intervals. From minus infinity to 0, from 0 to pi in half, and from pi in half to plus infinity. Minus infinity, plus infinity. Here 0, here pi in half, and in the first, in the middle interval, according to the condition, f of x is sine x. Here write f of x equals sine x. In the left and right intervals, that is outside this interval, f of x is 0. F of x is 0. In the first step, check the main probability equality for the continuous random variable. First step. Must verify this formula: minus integral from minus infinity to plus infinity, f of x dx is unit. It is the main probability equality. Separate this integral into 3 integrals. Integral from minus infinity to 0, f of x dx, plus integral from 0 to pi in half, f of x dx, plus integral from pi in half to plus infinity, f of x dx equals. In the first and in the third integrals, f of x is 0 according to this diagram. And here in the middle integral, f of x is sine x. We have, and you know that the integral of 0 are zeros. Integral from 0 to pi in half, sine x dx. The integrand is sine x, and its antiderivative is minus cosine x. Minus cosine x from 0 to pi in half equals minus cosine pi in half minus cosine of 0. Cosine is of pi in half is 0, and cosine of 0 is unit. Minus 0 minus 1, we have 1. this formula is verified. And here must remember the following equalities. Sine of 0 is 0. Cosine of 0 is 1. Sine of pi in half is unit, and cosine of pi in half is 0. Sine of pi is 0, and cosine of pi is minus 1. You must remember these formulas. Then go to the second step, next step. Second step. In the second step, we must find the mathematical expectation according to this formula. mx is integral from minus infinity to plus infinity x multiplied by fx dx. It is mathematical expectation for the continuous random variable. Separate this integral into three integrals. Integral from minus infinity to 0 x fx dx plus integral from 0 to pi in half of fx x multiplied by fx dx, and plus integral from pi in half to plus infinity of x fx dx. The first and third integrals f of x are zeros, and the middle integral, according to condition, it is sine x. Then we obtain the following integral from 0 to pi in half x sine x dx. We can calculate this integral by the as a method of the definite integration by parts, and for this we must introduce sine x into the differential sign. That is, must introduce sine x into the differential sign. And you know that the sine x dx is minus d cosine x. Integral from 0 to pi in half x multiplied by minus d cosine x. It is a anti-differential. Then take the negative sign out of the integral symbol. We have minus integral from 0 to pi in half x multiplied by d cosine x. Then denote x, change x by u, and cosine x change cosine x by v. Let it is u, but cosine x is v. And we obtain the following integral: minus integral from 0 to pi in half u dv. Then remember the formula of the definite integration by parts. Integral from a to b u dv equals u multiplied by v with double substitution from a to b minus integral from a to b v du. It is definite integration by parts. definite integration by parts. According to this formula, we have minus u multiplied by v with the double substitution from 0 to pi and half, minus integral from 0 to pi and half, v du. Then we can change the places of this integral. First write the second integral, because minus minus is plus. The integral from 0 to pi in half v du minus minus u multiplied by v with double substitution from 0 to pi in half. Then substitute x instead of u and cosine x instead of v. Integral from 0 to pi in half. Cosine x dx minus x multiplied cosine x from 0 to pi in half equals. Here integrand is cosine x, and cosine x, its antiderivative is sine x, simple sine x. Sine x with double substitution from 0 to pi in half minus pi in half multiplied by cosine of pi in half minus 0 multiplied by cosine of 0 equals. Here sine of pi in half minus sine of 0. Here cosine of pi in half is 0, and this term also is 0. And sine of 0 also 0. Minus 0 equals sine pi in half is unit. It is unit. That is, our expression is unit. And x is unit. Here x is unit. Now continue. Go to the third step. In this step, we must find the mx squared. Mx squared. Third step, mx squared. Mx squared. Mx squared is the integral from minus infinity to plus infinity. X squared multiplied by fx dx. Then again separate this integral into three integrals. Integral from minus infinity to 0 x squared f of x dx, plus integral from 0 to pi in half of x squared multiplied by f of x dx, and plus integral from pi in half to plus infinity of x squared multiplied by f of x dx equals. In the first and the third integrals, f of x are 0 according to condition, and in the middle integral, f of x is 1/4. Rewrite integral from 0 to pi in half x squared multiplied by 1. I'm sorry, but not 1/4. It's sine x. I'm sorry, sine x. Here, f of x is sine x. Sine x, x squared multiplied by sine x dx. Sine x dx equals. Here again introduce sine x into the differential sign for the application of the definite integration by parts. Sine x dx is minus d cosine x. D cosine x. Integral from 0 to pi and a half x squared multiplied by minus d cosine x. Then we can take negative sign out of the integral symbol. Integral from 0 to pi and a half minus x squared d cosine x. Here we must twice use the definite integration by parts. First, denote x squared, change x squared by u and cosine x by v. Then minus integral from 0 to pi and a half u dv. According to the definite integration by parts, we have minus u multiplied by v from 0 to pi and a half minus integral from 0 to pi and a half v du. Then substitute x squared instead of at first we can change the places of these terms. Integral from 0 to pi and a half v du minus u multiplied by v with the double substitution from 0 to pi and a half equals. Then substitute x squared instead of u and cosine x instead of v. Integral from 0 to pi and a half cosine x dx squared minus x squared multiplied by cosine x from 0 to pi and a half equals. Dx squared is 2x dx. Because dx squared is, according to the formula of differential, dx squared is the x squared prime dx. X squared prime is 2x, therefore we'll obtain 2x dx. Then continue and equals integral from 0 to pi and a half cosine x multiplied to x dx. Then substitute first substitute pi and a half instead of x. Pi and a half squared multiplied by cosine of pi and a half minus 0 squared multiplied by cosine 0 or 0. Cosine of pi in half is 0, and this term is also 0 because cosine of 0 multiplied by simply 0. And here we can take 2 out of the integral symbol and change the places of the x and cosine x equals 2 multiplied integral from 0 to pi and a half x multiplied by cosine x dx. Again apply the definite integration by parts. For this we must introduce cosine x into the differential sign, and you know that the cosine x dx is a d sine x. It is a formula of anti-differential, and 2 multiplied by integral from 0 to pi and a half x multiplied t sine x, t sine x. Then let x is u and sine x is v. Then we have 2 multiplied by integral from 0 to pi in half u dv. Then continue. We have the integral 2 multiplied by integral from 0 to pi in half u dv and equals 2 multiplied by uv with double substitution from 0 to pi in half minus integral from 0 to pi in half v du. Then substitute x instead of u and sine x instead of v. X multiplied by sine x with substitute from 0 to pi in half minus integral from 0 to pi in half sine x dx equals 2 multiplied by pi in half multiplied by sine pi in half minus 0 multiplied by sine of 0 minus, here integrand is sine x and its antiderivative is minus cosine x, minus cosine x with the double substitution from 0 to pi in half equals, it is 0 and it is unit 2 multiplied by pi in half multiplied by unit minus 0. Here we can write plus cosine x with double substitution from 0 to pi in half. Continue. 2 multiplied by pi in half plus cosine of pi in half minus cosine of 0. Cosine of pi in half is 0 and cosine of 0 is unit. Then we have equals 2 multiplied by pi in half minus 1, then it is pi minus 2. Therefore, then that is mx squared, we obtain that mx squared is pi minus 2. And finally, go to the last step, fourth step. In this step, already we can calculate the variance itself. Variance is dx according to the following formula. It is mx squared minus square of mx equals, it is the norm formula. Mx squared is pi minus 2 minus, and mx was be equal to unit squared is unit, and we have that it is pi minus 3. It is our answer. Finally, please rewrite your homework. The first example, the decibel density is 1/5 in the interval minus 2, 3, and f of x is equal to 0 outside this interval. In the second example, f of x density is cosine x is the interval 0 from 0 to pi in half, and here also f of x is 0 outside this interval. In both examples we must find the variance d or x. Find d or x. Find d or x. Thank you for your attention. Good luck. Goodbye, students.